Hello everyone. Welcome to my channel. Today, we'll explore the working principle of a 2x1 multiplexer, create a Verilog code for the multiplexer, develop a Verilog testbench to verify its functionality, and run a simulation. A 2x1 multiplexer is a combinational digital circuit that selects one of two input signals based on a control signal. It has three inputs, two data inputs, I0 and I1, and one control input, S, and one output, Y. When S is 0, the output Y is equal to I0. When S is 1, the output Y is equal to I1. This behavior makes it useful for data routing and selection in digital systems. Let us look at the Verilog code. I0 and I1 are the data inputs. Cell is the control input. Y is the output, and it's assigned based on the control signal. We check if cell is equal to 0, then we assign Y to I0, otherwise Y is assigned to I1. To test our multiplexer, we need a test bench. Our test bench, defined in the mux_2_1_tb.v file, is responsible for verifying the functionality of the 2x1 multiplexer by providing input values and observing the output. We instantiate the 2x1 multiplexer module, mux21, and connect its inputs and outputs to signals in the test bench. At the beginning of the simulation, we specify the VCD file, mux_2_1_tb.vcd, for waveform data storage. We use $dumpvars to specify which variables to include in the waveform dump. After executing the test cases, we use $finish to end the simulation. Now, let's observe the simulation results using a waveform viewer. Follow the instructions on the screen to open GTK Wave. Let's open the VCD file. The VCD file generated during the simulation provides a graphical representation of signal behavior over time. As cell selects either I0 or I1, we can see the output Y follows the selected input. The testbench and simulation results demonstrate that our 2x1 multiplexer behaves as expected. It selects the appropriate input based on the control signal SAL and routes it to the output Y. This is a fundamental concept in digital design and can be applied to various scenarios in digital circuits and systems. If you found this video helpful, don't forget to hit that like button, subscribe for more content, and as always, feel free to ask any questions in the comments below. Thank you for watching.